Hello, students. In the previous video, we learned the basic theory of the 8051 microcontroller. Now, let me ask you a question. If a microcontroller runs a program, does it execute instructions slowly or very fast? Yes, very fast. Sometimes too fast for real-world devices. So, what do? We introduce something called delay. Today, we will learn why delay is used, machine cycle concept, instruction cycles, labels and loops, inner, middle, and outer loops, how to create 1 second delay. Why do we use delay? Think about this. Suppose you want to blink an LED every 1 second. If there is no delay, what will happen? The LED will turn on an OFF extremely fast, and your eyes will not even see it blinking. Do you understand? If not, imagine a traffic light. Red, yellow, green. Each light must stay for a few seconds. Without delay, all lights would change instantly. So, delay helps the microcontroller match real-world timing. Machine cycle concept. Now, let's think about how the microcontroller measures time. The 8051 works using a clock frequency. Assume we use crystal frequency equal 212 megahertz. Do you know what this means? It means 12 million clock pulses per second. But the 8051 does not execute instructions in a single clock. It uses 12 clock pulses for one machine cycle. So, one machine cycle equal to 1 microseconds. Do you understand why machine cycle is important? Because delay calculation is based on machine cycles. Instructions cycle example. Now let's see 2 common instructions. Example 1. MOV R1 number 255. This instruction takes 1 machine cycle. Example 2. DJNZ R1 loop. This instruction takes 2 machine cycles. So every time we use instructions inside a loop, we can calculate the delay time. What is a label? Now look at this. Loop. This is called a label. A label is simply a name given to a location in the program. Why do we need it? Because some instructions need to jump back to a previous location. That is how we create loops. What is a loop? Now think about this code. Loop, DJNZ R1, loop. What happens here? The register R1 decreases by 1. If the value is not 0, the program jumps back to loop. So the instruction repeats again and again. This repetition creates delay. Inner, middle, and outer loops. Now let me ask you something. If one loop creates only a small delay, what can we do to create a long delay? Think about it. Yes, we can repeat the loop many times. That is why we use nested loops. 3 types: inner loop, middle loop, outer loop. Think about a real-world example. Imagine a school system. Inside a class, many students. Inside a grade, many class. S. Inside a school, many grad. ES. So the structure becomes student class school. Similarly in programming, inner loop, middle loop, outer loop. Example code structure. Do you see the pattern? The inner loop runs first. Then the middle loop repeats the inner loop. Then the outer loop repeats everything again. This creates a large delay. First, remember these important values. Remember, 1 machine cycle equals 1 microseconds. Assumption, 12 megahertz crystal. DJNZ instruction equals 2 machine cycles. MOV instruction equals 1 machine cycle. For delay calculation, we mainly consider the loop instruction DJNZ because it repeats many times. Step 1, target delay. Let's say we want 1 second delay. But instead of generating 1 second directly, we divide the delay into smaller parts. For example, outer loop delay equals 0.1 seconds. Then repeat it 10 times. So 0.1s times 10 is equal to 1 second. Do you understand the idea? Instead of calculating a large delay directly, we divide it into smaller delays and repeat them. Step 2, outer loop. Calculation. Assume the outer loop repeats 200 times. So outer delay equals 200 times inner delay. Now think, we want outer delay equals 0.1 seconds. So we write the equation. 0.1 is equal to 200 times y, where y equals inner loop delay. Now solve it. Y equals 0.1/200. Y equals 0.0005 seconds. Convert to microseconds. 0.0005 s equals 500 microsecond. So the inner loop must produce 500 s delay. Step 3, inner loop calculation. Now remember, DJNZ takes 2s. So we calculate how many repetitions we need. 500 microseconds/2 microsecond equals 250. Do you see what happened? That means the inner loop must repeat 250 times. Step 4, verify the delay. Now let's verify the delay step by step. Inner loop, 250 by 2 microsecond equals 500 microsecond. So inner loop delay equals 500 microsecond. Middle/outer level, 500 microsecond times 200 equals 100,000 s. Convert to seconds. 100,000 microsecond equals 0.1 seconds. So now we have outer loop delay equals 0.1 seconds. Step 5, final delay. Now repeat the outer loop 10 times. 0.1 times 10 is equal to 1 second. So the final delay becomes 1 second. Do you understand now? If not, think again step by step. Instructions: cycle, inner loop, outer loop, repeated delay. Start with a basic LED program. Will the LED blink? Yes, but too fast to see. So we must add delay between on and off. Add delay call. Now modify the code. Where's the delay program? We must write the delay subroutine. Now introduce the label. A label is just a name for a program location. So we write delay. Now students understand why delay exists. One instruction gives only a very small delay. How can we create a long delay? Think. Yes, repeat instructions many times. That means we need loops. Start with the smallest loop. MOVR1, #250. Enter DJNZR1 in R. First, R1 equals 250. Then DJNZ runs. 250 minus 1 is equal to 249. Is it Z? RO? No. So jump back to enter. This continues until R1 becomes 0. Is this delay large enough? No. So we repeat the inner loop many times. Add middle loop. MOVR2, #200. Middle, MOVR1, #250. Enter. DJNZR1, enter. DJNZR2, middle. Every time R2 decreases, the inner loop runs again. Still not enough delay. So add one more loop. MOVR3, #10. Outer, MOVR2, #200. Middle, MOVR1, #250. Inner, DJNZR1, inner. DJNZR2, middle. DJNZR3, outer. Now see 3 loops. Inner, small delay. Middle repeats inner. Outer repeats middle. Finally add RET. RET means return to the main program. So after delay finishes, the program goes back to the LED code. Final complete program. Do you understand how delay works? If yes, great. If not, try to think step by step. Machine cycle instructions, cycle, loop, nested loops, delay calculation.